Good morning, folks. I'm welcoming you back to our tanker lab tutorial. This will be 3 or 4 parts, but what we're going to do is talk about the pump room today. Now, I want you to recognize what we would be doing if we had the time, if we didn't have these first 2 weeks under COVID we would be in the class together and we would be analyzing a lot of this information, and you'd be able to visualize more readily what we're talking about. So you need to kind of wrap your head around this a little bit. I know you have you're not in a position where you can really visualize this, but if we learn how the system functions, if we look at it as from a functional perspective, when you get down in there, you'll be able to make sense of it. Now, I'm going to provide you with an awful lot of information that normally isn't provided. In other words, in the past, we've had time for you to go down into the lab, trace the system out, and you have to figure it out yourselves. Of course, I give you a little help on that. I mean, you're not in it alone. But this time what I'm going to try to do is to expedite this a little bit more and give you the functionality of the system itself so that you can make sense of it when you finally get to work on it. So we're going to talk about the pump room today. And when you go down there for the first time, you look at that spaghetti down there and you say, what the heck is this all about? How am I supposed to see my way through this? Now, I understand that some of you are very good at this sort of thing. Some people are inherently good at analyzing systems. Congratulations, you're part of the minority, because a lot of people really can't even see how these things work until they actually start to work them together. So I'm going to try to get you through the system as efficiently as possible. Okay, so when we look at the pump room here for the first time, you go, oh my gosh, what is this? How am I supposed to find my way through here? Now this picture was taken before anybody had ever used the system. It looks nice and clean and pristine. Not so much anymore. It's been used. It's functionally been misused over the years and so forth. And she's starting to feel her wear a little bit, but it's still pretty much the same. When you look down into the pump room, you'll see a lot of squirrels, a lot of spaghetti down there. You'll see a bunch of different components, and you'll see a lot of valves. And you can see multicolored valves. And from the past, look at this, we have crossover valves. Isn't that what this is? A red and a yellow. It means it's a crossover valve. All right, so, looking down into that, you've already got some information you could look at. The numbering on the valves are going to be very, very important, and that's going to be your job. I'm not going to give you the numbers of these valves, because when you have your drawing set up and everything is going well, you have to get down there and trace this out. It's one thing to draw. It's another thing to make that 2D drawing into a 3D drawing, and then be able to recognize where these valves are and how they're numbered. Now, the valves are numbered now, no longer with these discs. They didn't last very long, so you're going to have a Sharpie numbering system on here. So make sure that in your drawing, this valve represents what's on your drawing. Okay, so when I draw one of these things out, I look at what are the major components, what are they supposed to do, and how do they work within the system. So the major components that we're going to be looking at is within here you have 3 main cargo pumps. Okay, there's the yellow one, there's the red one, there's the green one. Remember out on deck? They had red, yellow, green systems. Okay, so they each have their own independent pumps, main cargo pumps. I also have, tucked down here in the corner, you can't see it from this angle, but there's another one of these pumps. It's blue, and it's the ballast pump. You also have 2 stripping pumps up here. Now, the stripping pumps are a little bit different than these. These are kinetic pumps. These are positive displacement pumps. We'll make sense of those 2 terms as we move forward in our classes during the lectures and so forth, what the value of positive displacement versus a kinetic pump are. You also have cargo eductors. You have two cargo eductors. Now, if you look down, this is the starboard side of the pump room here. If you look down from the port side, you can see these brass fittings. There's one here. There's another one behind this valve here, a brass fitting. Those are eductors. You also have one on the ballast side. If we go over to the starboard side and look over here to the port side, you'll be able to see another eductor down here. Independent ballast. By the way, cargo and ballast do not meet. We have a segregated ballast system, which means cargo, they do not integrate with the cargo systems at all. You have segregated tanks, you have a segregated system just for ballast. Okay? But these are the main components. When you're analyzing the main components, we look at them. You say, so you have the three main cargo pumps. What do I want those pumps to do? I want those pumps, first of all, they're kinetic pumps. And when I talk about kinetic pumps, we're looking at centrifugal forces, spinny-roundy pumps, things that take a volume in and kind of use centrifugal force to kick it out. We'll look at those again. We'll talk more about those as we go on, but just recognize that these three pumps and the ballast pumps are centrifugal pumps, also referred to as kinetic pumps. You'll hear those terms. A centrifugal pump is a kinetic pump. Again, more to be talked about when we get into the lectures. What do I want it to do? I want it to bulk discharge the cargo. I want to just take that cargo out and get it out of there, right? And I also want it to feed the eductor, to make the eductor work, right? I have a ballast pump. It too is a kinetic pump or a centrifugal pump. It's designed to load and discharge, let's put it this way, load or discharge ballast onto the ship. And it's going to take ballast from the sea, from the pool, put it into a tank. It's going to take ballast water from the tank and put it into the pool. Okay? But I only have one pump. It's not two independent pumps to do these things. It too is going to have an eductor on it, and that system has to be able to feed the eductor. We'll make sense of what that means here in a minute. You have two stripping pumps, a positive displacement pump, and a positive displacement pump. Basically, it takes a volume in and spits a volume out. It takes a volume in and spits a volume out. It's not, it's happening very, very quickly, but there are some advantages to a positive displacement pump over a kinetic pump. And like I say, I have a whole series that we're going to be talking about when we talk about pumps. We'll talk about the differences. But for now, just understand that they're different. So the stripping pumps are positive displacement pumps. So I have one independent for the yellow system, but I should have three, shouldn't I? I have three cargo systems. I have three stripping systems. Why do I only have two stripping pumps? Well, it tells me that I'm going to have to use one of the stripping pumps is going to be used for either the green or the red. And you're going like, oh my God, what if I'm loading or discharging diesel out of the red system and gasoline out of the green system, and I'm going to use the same stripping pump? Seems to me like we might have a contamination problem. So we're going to have to kind of be careful about that as we move forward. What else? So then we have the red and green stripping pump, and that we're going to be using those as a positive displacement pump to pump the last bits of the cargo out. We also have two cargo eductors, and those cargo eductors are going to be used also for stripping. And you also have one ballast eductor. We don't have a separate stripping pump for the ballast system. Remember, out on the main deck, there were no stripper valves for the ballast system. It was what was one of the unique things about it. So we're going to be using the same valves to strip out that we would be for pumping it out as well as for stripping it out. So that has to be all in play too. And that's what we're going to ask the ballast system to do, is pump water out, pump water in, and drive the eductor so that we can strip out one of the ballast tanks. So if you know fundamentally what the components are, what you're asking them to do, then it's just a matter of putting it all together. So before we go too far, let's talk about how an eductor works and why it's important. So an eductor is a stripping pump. We can use the eductor as a stripping pump, and we're going to use it, we have to create flow through the eductor so that it can create a vacuum within the eductor. So by taking, let's say we have, we're going to strip out number 1 center line tank using the eductor. But in order to use the eductor, I have to have flow going through it from another tank. So let's say number 6 tank is full, and I'm pumping number 6 cargo through the eductor. So I would take it through the eductor from the tank through the cargo pump, creating pressure, pushing it through the eductor and out. And as it does that, it squeezes down. You can see it squeeze down, creates velocity. And when that velocity increases, what you're going to, in turn, what you'll get is a suction, a vacuum coming through here. So I'm creating a vacuum using the main cargo pump to discharge, to create the flow, which is going to create the vacuum. And you say, well, what the hell's the sense of that? Why not just use the pump? Well, when we start running out of product, when we get down to the bottom, and the pump is not really filled up with any kind of volume of liquid anymore, that pump, it needs to have that volume. The centrifugal pump needs to be full. I'm going to use the term fat, dumb, and happy all the time. If you can keep that pump impeller full, it's going to pump all day long. But when you start running out of product and you start getting a combination of air and volume and liquid through there, you get this kind of bubbly effect, and the pump just hates it. We're going to find out that pumps really don't like air at all. So what this allows us to do is it allows us to keep the pump happy. It is discharging cargo at the same time. We're still moving cargo out of there, but it also provides a nice little vacuum source for, let's say, the emptier tank. Now, if all of a sudden this tank starts getting air in there, well, what happens? As the liquid is flowing through here and this liquid is coming up, it mixes together here and it all goes out together as one solid chunk of liquid. I don't want to say liquid. It all goes out as one liquid. So one thing we have to be very careful about with an eductor is that whatever you're using to drive the eductor has to be the same product as what you're trying to draw out of it. You can't have diesel going through here and suck in gasoline, because whatever's coming out is going to be a combination of diesel and gasoline. You just contaminated the cargo. So it has to be the same product. But what is nice about it is, as this tank goes dry and gets a lot of air in there, and now you've got this volume of air, it's not going to hurt the pump at all. You can just let it suck all day long. It'll take that air, that volume out of there. It doesn't care if it's air, it doesn't care if it's liquid, it doesn't care. Right? So we can, just basically open up a stripping line and just let it go until it goes dry. And if it goes dry, so what? If it was a pump, and we were pumping it out and it goes dry, now that pump is getting all kind of work. It's not working efficiently anymore, and it's going to start running away from you. It doesn't have that resistance that it loves. So for stripping purposes, and particularly when we're going to start talking about tank cleaning, when we're always looking at these tanks being on the verge of being dry all the time, these eductors are very, very effective. So for our conversation, what do we need? We need this cargo pump to be able to drive the eductor. We need a way of doing this. So keep that in mind. By the way, you're going to have a pressure gauge on this side of the eductor, because there's going to be a pressure increase as we start to squeeze it down. It's going to have a little pressure increase. And the vacuum will be on the suction side of the eductor. On the stripping line, when it's coming in, we want to see that it's creating a vacuum. On many ships, on most ships, you will have a pressure gauge on both sides of the eductor. You want to see what the pressure differential is going to be, because as this stuff starts to fill up, you're going to have a change in pressure, what's going in and what's coming out. All right. little more than we need to talk about right now. But just recognize in your drawing you should have a pressure gauge on this side of the adductor and a vacuum gauge on this side of the adductor. Moving on, so here we're going to look at the yellow system. And what I like to do is I like to draw the main components first. What are the main components? Well, yeah, we have a main cargo pump, we have an eductor, we have a stripping pump. Those are my main things. What do I want the main cargo pump to do? Well, I want to take cargo out and pump it ashore. By the way, this is the symbol right here for a riser, where it comes out of the pump room under pressure and goes up to the main deck, the riser. So here we have a street that goes through the pump. I have what we call the recirculation line. If you look at this, here's the main thing that you have to first focus in on, is that on this side of the pump it's vacuum. You're sucking stuff into the pump, and on this side of the pump it's pressure. Vacuum to pressure, right at that pump. So as I'm coming in here, I'm under vacuum, and now I can recirculate that. So it goes under pressure, it goes right back to the vacuum. It circulates around here. All three of our pumps, all three of our cargo pumps have that, a recirc line. And once again, look at what is the same in every system and what might be different. Right? This would be the same. So if I were to put these three components in for the green system, the red system, and the yellow system, fundamentally it should work the same. So there's a recirc line. Now I'm also, remember, vacuum in, pressure out, pressure goes through here. I want it to go ashore, boom, goes ashore. Or I want it to be able to transfer that energy and go through the adductor to create the vacuum that I need for the stripping line and recirculate around like that. There's your street. What else do we need? Well, we need the stripping line. So in comes the stripping line. Now the stripping line, I want it to be able to draw a vacuum using the adductor, or I want it to be able to draw a vacuum using the stripping pump, and it's all going to be discharged ashore. Okay, so let's say I'm going to use the adductor. I'm going to take cargo from one tank, swirl it around, bring it up through here, have it feeding. Here's that flow going through the adductor, going over here to the discharge side of things, creating the vacuum here, which is going to draw down this line here, the stripping line, the yellow system. Fundamentally, this is what it needs to be. Now, obviously, it can't work until we put the valves in. So let's see what the valves look like. Each one of these systems will have an isolation valve. Okay, so we have basically the bulkhead, let's say the bulkhead between the cargo tanks would be on this side here. You got the bulkhead through here. So here's the valve that's going to isolate the pump room. Here's the one that's going to isolate the stripping line of the pump room. In order for me to pump cargo out, all I want to do is pump cargo out. Here's what I have to do. I have to open up this valve. That allows cargo into the pump. I don't want it to recirculate around, so I'm going to close this valve. I don't want it to go into the adductor, so I'm going to close these two valves, and I'm going to open up this valve. So all I really need to do is open up two valves, this one and this one, start up, open up the cargo tank, get cargo flowing into the pump, and away we go. Now, I changed my mind. Now I want to run the adductor. So I'm going to open this up. I'm going to run through the cargo pump. I'm going to go up through the eductor. So this valve would be closed. This would be open. This would be open. This allows flow to go through here. If I allow this one to stay open, if I forgot to close this one, now most of the energy is going to go through here. I'm not going to get enough circulation through here to create the vacuum. So there it is. I open this one, bring cargo through it, close this one, force it up into here, force it into here, up and out. Now in order to use the adductor, I'm going to have to open this valve, and I'm going to open up this valve. So this is going to come from the cargo tank through into the pump room, use the adductor, swirl around together, discharge together, and up and out. I'm going to close this valve. Now let's just say I don't want to use the adductor. I'm down into my last tank and I have the last bits to get out of my last tank, and I ran the thing dry. So I would close off the main cargo pump. I would close off this isolation valve. I would close off the adductor feeds and so forth. And I would simply open up the stripping isolation valve, close it to the adductor, open it up to the suction side of the stripping pump, and discharge ashore. 1, 2 valves and off, and then we start this pump, creating the vacuum and suck out the last bits. Now there's something fundamentally wrong with this layout in the yellow system. Fundamentally. What would happen? Remember, we open this up, we start the cargo pump, we open up the pump discharge. So we take suction into the pump, discharge up to this pressure. So I got pressure up to this valve, it stops. I have pressure up to this valve, it stops. I have this valve open, but it not only is it allowing to go ashore, it's also allowing to go in and put some pressure on the back end of the stripping pump, which is probably not the best thing for it. So reality is that this should have another valve right here to isolate the stripping pump. It should be there, but when they built our system, it's not there. So when I'm looking at all three systems, fundamentally, to work properly, I need 1, 2, 3, 4, 5, 6, 7, 8, 9 valves. So when we draw out the rest of the systems here, we should, for each system, have 9 valves associated with it. Okay. Think this through for a minute. Let's jump on. So if I go now and I take that thought process and I put my green pump, my red pump, here's the adductor, and here's my stripping pump, and I'm going to share those two. Now I have to do that in such a way that I do not contaminate cargo. So let's see how that plays out. The first thing, here's my cargo line, just like the yellow line, up and out. Here's my red one, up and out. No big deal. The next thing is I want to be able to take the green and feed the adductor and go up and out this way. Also, I want to have the option of feeding the red system, feed the red adductor, red line through the adductor up and out. So you can see the adductor is sharing, we're sharing it with the red and the green system. Obviously, the potential for contamination of cargo is pretty severe right here. Let's go on, let's put the rest of it in. Here's the stripping line. So the stripping line comes in here. So the red stripping line would come in through here, and it says, look, I can bump into the green line here and go through the adductor and discharge ashore. Or if I have the red flowing through the adductor creating a vacuum here, I could come down this line and come out, use the adductor to come up and out. Or I could do it with a green. Here's a green line. Let's feed the adductor through the green line, up and out. Now here comes the vacuum. I have the vacuum coming through here. At this point, it's red or green. It could go either way. It goes through the adductor, up and out. Or I can come through this side here, not go through the adductor, but actually go through the stripping pump, up and out. Let's make things even more complicated. On the suction side of the pumps, be it the adductor, the stripping pump, or the main cargo pump, I put a series of crossovers in there. Crossovers allow versatility, but they also provide a lot of complexity into the system. The more complex the system, the more you can do with it. But this is all on the suction side of the pump. So what it's saying is here, on the suction side, as I'm coming into the pump room, I can cross over my red and my yellow system, or my red and my green system, or my green and my yellow system. I can cross these over. Now let's see, what does that do for me? It says, well, if my red pump is screwed up and I have to go into my yellow pump with whatever's coming down the red system, I can do that. Or I could use the green pump. Or what I could do is open up all three crossovers and use all three pumps on the same product going out. If I have the same, let's say the whole ship is full of gasoline, and I want to maximize my discharge, I can put all three pumps, and here's the term that we use, in common. In other words, all three pumps are working on any of the three tanks, any of the three systems that we have out there. And I can do that by opening up these crossovers. Well, I can also do that on the stripping side. I can cross over the stripping lines as well. Again, it makes the system more complex. We have to be very careful with crossovers that we do not contaminate. We don't have them open when they don't need to be open, where there's a potential of contamination. But this is all on the suction side of the pump. Now I have the versatility that I can play with here. Cool. All right. Let's put some valves in here. Boom. Now, I've given you this. What you have to do is, one, in your mind, make sense of how these valves are working. And I'm not giving you the numbering system. You're going to have to get down into the tanker, take your drawing with you, and make sense of what you're seeing, as well as the valve layouts, and give me the proper number for the valve. You cannot operate this ship if you don't know what you're doing. So you go and you gap this off of your roommate or something like that. Well, congratulations, you finished the drawing, but you have no idea what you just did, and you're going to need that drawing. You're going to need to know how this system works to be able to operate it successfully. So let's just take a look here. Let's play the game. First of all, how many valves do we need in each one of the systems? Now, I'm not talking crossovers, just the fundamental valves. Let's make sure that we have the right amount of valves here. So the green system has 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, we have enough valves there. Hopefully they're in the right spots, but we have enough valves. How about the red? 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, this is a valve that's missing. That's why we only have 8. This valve is missing in the yellow system. So nine valves. So the number of valves is correct. That's always the first job. The next thing that I would look for in a drawing is that if I have to open up 2 valves, let's say in order for me to strip out a cargo, I had 2 valves in a row here that needed to be opened. Chances are one of those valves is in the wrong place. A red flag would pop up if I said, as I'm drawing through this and I have to open up 2 valves to make something work. It's not right. Anyway, so let's do this. Can I discharge? Well, let's say, can I strip? First of all, let's discharge the green. So I'm going to open up this valve here. I'm going to close the crossovers. Crossovers are closed. I'm going to close the recirc valve. I'm going to close this one. Oh, look at that. That feeds the eductor. That's going to be closed. That's going to be closed. This one's going to be open. I'm going to just pump it right out. And this one, these 2 are going to be closed. Okay. By the way, this valve right here and this valve right here would be the one that we're missing here. Okay, so I can pump that out. Can I do it with the red? Yep. Okay, I'm going to open this up with the red. I'm going to close the recirc line. I'm going to close the eductor feed, the eductor discharge, and the stripper discharge. Open up this. I only have to open up 2 valves. 1, 2. Start up the pump, and away I go. All right. The next test. Can I strip out the red system at the same time I'm stripping out the green system? I'm going to strip out the red system in this diagram with the eductor, and at the same time strip out the green system with the stripping pump. Can I do that without contamination? All right, so we'll open this up. We'll start to flow through here, but it's not going to go ashore directly. We're going to close this valve, force that liquid up into here, up and out. Now the pressure is going to come up through here, it's going to go through here and going to go down through there, but it's also going to want to go up to here until it hits that valve. It's not going to go any further. As it's being discharged, you want to make sure that this valve is closed, this valve is open, there's my circulation for the adductor. Driving through, up, over, down and out. Now I want to feed the adductor, I'm going to create a vacuum through the adductor with the red system so that I can go down the stripping line. So here I have this valve open, my crossovers are all closed on the stripping line, and instead of going down on this side, I'm going to come down through here on this side. So let's make sure that this valve is closed. Come up through here. Remember, we're under vacuum. I'm going to be drawing in here. Here's the vacuum coming into the adductor. It mixes together. It's not discharging to the green, it's discharging to the red. So I have flow going. Let's look at that. Flow, I'm going to open this, open that, close that. Creating the flow, creating the vacuum, coming down the red stripping line, down through here. I'm going to open up this valve here, which is a eductor suction line on the red system, making sure that this green line is closed, and then coming up and out. Now I said at the same time, I want to be able to draw a vacuum on or strip out the green system. Remember, can't contaminate. So what do? I'm going to use my stripping pump here. Let's try that. I'm going to open up this isolation valve. Here comes vacuum. I'm creating the vacuum with this pump, not with the adductor, just with a pump. It's coming up and up through here. This valve is open, this valve is closed because this side is contaminated with a red cargo, right? I'm coming up through here. This valve had better be closed, otherwise I'm going to be drawing red and green cargo in at the same time. Don't want to. It's isolated. Here's the vacuum coming into the pump, pumping it out. This valve is open. Coming in through the green. This valve is open. Oops. This valve is open, and I'm discharging up and through here. So at this point right here, you have red cargo contaminating this line. If this valve is open, you're going to contaminate. But with these valves closed, I can keep my system pure. Green to green, red to red. So that's the proof that's in the pudding. Can I do this? Can I operate both ways? Once you figured out, oh yeah, I can do this without contaminating, doing it that way, with the red going through the adductor and the green going through the stripping pump, can I do it the other way? Can I have the green going through the adductor and the red going through the stripping pump and not have a contamination situation? That's what you have to look for in this system. Now, additionally, we're going to make sense out of these gauges here. These gauges on the side are for the eductors. You have two on this side and one on the port side. The one on the port side is for the ballast system, the ballast eductor, and the starboard side is for the two cargo eductors. And again, remember, the vacuum side would be on the side that is you're drawing from. So that would be on the stripper line coming into it. And the pressure side would be as you're coming into the adductor, you would have a pressure gauge here. You would have it for this system. So here's 1 and 2, 3 and 4. This is for the yellow system, and this would be for the red or the green system. Because at this point, remember, this is where it gets kind of squirrely. This is where you can contaminate. That's why I have it multicolored like this. You have to be careful not to contaminate here. But as far as the adductor is concerned, this is the vacuum side, this is the pressure side, irregardless of which cargo, red or green, is coming into it. Analyze this. Make sure that you understand how this system is fundamentally supposed to work. Because what we've really done now is we've taken the spaghetti, which was once a bowl of spaghetti, and now we have integrated it into a usable system. That leads us to the last system in here, and I'm not going to go any further with this. I'm going to allow you to analyze this. I will give you a homework assignment, and what I want you to do is put the valves in that are required to be put in here. I'm not going to tell you how many valves are needed, but what I will do is kind of walk you through the ballast system. Now, the ballast system, remember, is only one pump, and it is not reversible. In other words, this side of the pump is always going to be the suction side, and this side of the pump is always going to be the discharge side. What I have to do now is work the system to make sure, put the valves in place so that I can do what it's supposed to do. What is it supposed to do? It's supposed to take ballast from a tank and put it out overboard to the overboard discharge. It's supposed to take ballast water from the sea and be able to transfer it into the cargo tank. From the sea, remember this is the suction side, this is the discharge side. So it's discharge, suction, into the tank. And the other thing I'm going to ask it to do is run an eductor so that I can strip it out. So how would I run the eductor? Well, I would run the eductor up, take suction from the sea, go through the pump. Instead of going right overboard, I would go through the eductor from sea to sea and out, like that. There's my flow through the eductor. And here is what I'm trying to do. I'm trying to draw a vacuum using the eductor here. So everything goes from sea to sea. Okay. This, by the way, is not the arrowhead. This is the bell of the eductor. So here's the base of the eductor, and that's the discharge side of the eductor. I want you to think this through, and this will be your first assignment as far as getting to know this system a little bit better. So I know we've talked a lot. There's a lot going on here. But what I want you to do is take that spaghetti and be able to analyze it and make sure that you understand how it works. Secondly, you have to remember that you're going to be giving people orders. Open this valve, open that valve. This valve has to be open. If you're the pumpman, this is your realm. You should know this pumping system. If things start to go wrong, you should be able to manipulate the system in an efficient way where you can get the pumps coming back. And so you need to know the system. For the mate and the mate on deck, for the PIC and the mate on deck, you're going to be giving orders. And the only way you can give orders in through the pump room, going through the pump room, is to make sure that those valves are open and the valves are numbered correctly so that you get the flow that you're looking for. So your drawing has to have those valve numbers on there. But more importantly, you need to be in a position where you understand exactly what you're trying to do within that system. It's going to sound like, I don't know what the hell I'm doing. Yeah, okay, fine. But over time you will. And every time we run one of these scenarios, every time we run a simulation, you should be paying attention as if you were the PIC giving these orders to make sure that you understand exactly what's going on. When you're working a tanker, this is one of those things that you have to be very, very careful about, and you have to understand this, is that you are in charge, or you're going to be asked to be in charge throughout your watch, whatever the such scenario is. Either you're going to be the chief mate who's going to be overall in charge, or you're going to be standing a watch out there, and you need to know what's happening on your vessel. Not only do you need to know what's happening now, I used to play the what if game. What if this happened? What if I had a spill? What would my reaction be? How would I deal with it? What if this pump started to draw air? What is my reaction? Those are the fundamental things. You have to be able to know what your system is capable of doing before you can troubleshoot something, or before you can make changes which are going to correct things. And this is what we're dealing with. So here you have it. You have it all laid out for you. And like I said, this is the first year that I've given this drawing out. Most people would, and in previous years, you would have had to get down to that lab, go down in your free time, draw it out. My expectation is, now that I've drawn it out for you, that you put it into a working document and you understand the system. This is not a gap, because I should be able to ask you very specific questions when you get into the lab. What does this valve do? What does that valve do? All that kind of stuff. And you should be able to talk the talk and walk the walk of getting this job done. Hopefully this will work. But if you have any questions, don't hesitate to ask. Cool. I look forward to moving on with you within the labs. Stop.